Good morning. This is the audio lecture for visually impaired student on the topic of water pollution. Water in abundant amounts is required for use in agriculture, industry and household. After use, however, it gets highly polluted. The various water pollutants can be classified into as many as 10 categories. These are discussed below in some details. Various water pollutants. Number 1. Sewage and other oxygen demanding wastes. Sewage from municipalities and other oxygen demanding wastes from industry and agriculture comprise of organic matter which undergo oxidation readily under the action of microorganisms. These wastes are generally disposed of by dumping them into nearby rivers. If the amount of sewage or other wastes discharged is relatively small, the dissolved oxygen is sufficient to convert carbon into carbon dioxide, sulfur into sulfates, phosphorus into phosphates, and nitrogen into ammonia and nitrates, and the river water is not so badly polluted. If, however, the amount of discharge is heavy and the dissolved oxygen become insufficient, carbon is converted to methane and nitrogen compounds are converted to amines, which give offensive odor of rotten fish decaying in a cesspool. The sulfur compounds change into hydrogen sulfide, which gives smell like that of rotten eggs, and phosphorus compound produce give a wormy odor. Thus, sewage and other oxygen demanding wastes become water pollutants on two accounts. 1. They give rise to compounds which have an extremely annoying odor. Second, they deplete the dissolved oxygen from water, which is rendered harmful because water devoid of dissolved oxygen cannot sustain aquatic life. It affects or even kills fish and other aquatic living beings. Second, infectious agents. Sewage from municipalities is almost invariably associated with disease microorganisms. This is due to the fact that in a fair sized community, a few inhabitants at any given time must be suffering from diseases such as dysentery, typhoid, etc. The feces and urine of such patients would contain disease microorganisms which are transmitted through water supplies. Thus, wastewater from municipalities would almost invariably carry agents, bacteria, or other microorganisms which produce disease in other living beings, men and animals, including livestock. Third, plant nutrients. The presence of plant nutrients in lake and slow moving water introduced through runoffs from farmland, sewage treatment discharges, and from fertilizers factories supports high population of aquatic plants which on decay produce disagreeable odor. Not only this, these plants also deplete dissolved oxygen, making the survival of aquatic life like fish problematic. The enrichment of water by nutrients is known as eutrophication. Lakes and slow moving water age through eutrophication, and over periods of several millennia, they get converted into swamps and marshes. Eutrophication has an adverse effect on fish as well. The aquatic plant which bloom in lakes sink in autumn and winter and decay the next summer, depleting oxygen from the lower colder parts of the lake. The cold water fish, which according to Darwin's theory get habituated to require more oxygen, cold water dissolves more oxygen for their growth, have to face shortage of dissolved oxygen. As a result, the cold water fish lose out to warm water fish, which needs less oxygen. Humans who prefer cold water fish are thus deprived of getting their choice fish. Number fourth, exotic organic chemicals. The exotic organic chemicals include pesticides, surfactants, amongst detergents, many industrial products, and several decomposition products of other organic compounds. Analysis of polluted water reveals the presence of a wide cross section of these compounds as also many others. These organic chemicals are generally toxic to fish, Some of these are toxic even at extremely low concentrations, around 1 parts per million. With the fast development of chemical industry, several new organic chemical compounds are introduced every year which may find their way into rivers and lakes. Since the effects of these new compounds on natural ecosystems may not be known, there is every possibility that an irreparable damage is done before scientists release it. Number 5. Organic minerals and chemical compounds. A large variety of inorganic chemicals find their way into normal water from municipal and industrial waste waters and urban runoffs. These pollutants, comprising of compounds of HG, arsenic, cadmium, sodium, calcium, etc., injure or kill fish and other aquatic life and also render the water unfit for drinking or not for industrial use. A prominent example is the presence of mercury in water. At one time, it was believed that metallic mercury sinks into the sediments and remain there in chemically inert metabolic form. But now it is known that anaerobic bacteria in bottom muds convert inorganic mercury into methyl mercury CH3Hg positive, which can lead to mercury poisoning in living beings. In petroleum drilling, brine is discharged along with crude oil. When the latter is pumped to the surface, sometimes the volume of brine may be more than 3 times the volume of crude oil recovered. This brine is a potential pollutant for water. Minerals containing sulfur, example iron pyrites, copper pyrites. On coming in contact with air and water yield sulfuric acid, which is carried into lakes and rivers by water draining from mines. The presence of acid affects aquatic life. In cold countries, NaCl and Cl2 are added in large amount to melt snow from roads in winter. These salts eventually run off the roads and contaminate well water and also find their way into lake and rivers and seriously affect the aquatic life. Some other metals whose compounds frequently act as water pollutants are lead, arsenic and cadmium. Lead. Compound of lead which enter into water are PbCl2, PbBr2, PbBrCl, PbO, PbS, which originate from lead minerals. Lead in the form of PbOH twice gets entry into water from lead pipes. Excessive intake of lead by human causes disruption of synthesis of hemoglobin. It also results in the loss of appetite, anemia, kidney malfunctioning, nervous disorder, and brain damage. Arsenic. The main sources of arsenic compound in water are pesticides, fungicides, and herbicides. Arsenic contamination may also occur due to discharge of some industrial wastes, dissolution of arsenic minerals in another source of arsenic compounds. Arsenic third compounds are highly toxic. The toxicity arises from the complexation of arsenic 3 with the SH group of enzyme, which leads to inhibition of enzymatic action in human body. Since arsenic is structurally similar to phosphorus, its presence interferes with the process of phosphorylation in human body. Higher doses of arsenic result in coagulation of protein, which causes cramps, paralysis, and even death. Cadmium. Cadmium finds its way into water from industrial discharge and from nickel cadmium batteries. It is highly toxic. Excessive dose causes kidney malfunctioning, anemia, disorder of bone marrow, etc. It may be mentioned that according to the International Register of Potentially Toxic Chemicals of United Nations Environment Program, there are nearly 5 million known chemicals in world today and about 40,000 new chemicals are added to this list every year. Of these, about 75,000 chemicals are in common use, amongst which a large number are positively known to be toxic. A brief list of toxic elements whose toxic ions are most commonly present in municipal and industrial water is given below. Like arsenic come from the sources pesticides, chemical wastage, mining byproduct, and their adverse effect is enzyme inhibitor. Like cadmium, its source are industrial discharge, metal plating, nickel cadmium battery, mining wastage, etc. And the adverse effect is cause high blood pressure, kidney malfunctioning, anemia, and disorder of bone marrow. Elements like chromium, copper, lead, manganese, zinc all have their sources and their adverse effects. Some are toxic to plants, to animals, etc. are given here. As it is well known, the normal growth and development of animal and human beings are brought about by specific enzyme present in the body. The toxic ions in general attack the active sites of these enzymes, react with the SH group of enzyme and thus cause their complete inactivation. The functioning of metalloenzymes is inhibited by the replacement of harmless metal ions of the enzyme by toxic metal ions. It is to be noted patently that it is not the presence of a particular chemical but its concentration which actually matters in chemical toxicology. Those elements such as arsenic, aluminium, barium, beryllium, cadmium, copper, cobalt, etc., Hg, etc., which are listed as environmental hazards, act as nutrients in trace concentration and are essential for normal growth and development of animals and human beings. Arsenic trioxide, are deadly poison, is known to act as a tonic at trace concentrations. This means that for pollution control, we have only to control the concentration of toxic elements. Any number of toxic elements may be present in drinking water, but as long as their concentration are below the prescribed limits, they are harmless. The permissible limits for some common elements are laid down by United States Public Health. Drinking water standards are also given here. The Bureau of Indian Standard values, wherever available, are also listed in this. The drinking water should be colorless and odorless. Its pH should be lie between 6 and 9. It should be free from harmful microorganisms and its dissolved oxygen content should be lie in between 4 and 6 ppm. It should not contain the above mentioned chemical beyond their permissible limits of concentration. Number 6, sediments. Sediments are particles of soil and mineral which are washed from croplands, undeveloped land, unprotected forests, soils, or grazed pastures, strip mines, roads, floods, water sediments fill reservoir and stem channels, plug water filter, erode power turbines and pumping equipment, and reduce the amount of sunlight available to green aquatic plants. The sediments also cover the fish nest, the eggs laid by them in water, and their food supplies. This reduces the population of fish and shellfish. Number 7, radioactive substances. Radioactive substances from nuclear power plants, wastes of uranium and thorium, mining and refining, and from industries and institutions which utilize radioactive materials, if carried by water, become sources of harmful radiations. Number 8, heat. Large amount of water are used for cooling purpose in thermal and nuclear power plants. Water is also used as a coolant in some industries. Cooling water is thus discharged at a raised temperature. The increased temperature have several adverse effects on certain properties of water. The rates at which chemical reaction occurs increase considerably. This results in faster assimilation of water wastes and hence faster depletion of dissolved oxygen, which affect aquatic life. The rate of evaporation also increases appreciably with increase in temperature. This results in greater wastage of water in form of its vapor and so on. And 9, oil. Oil pollution results from the discharge of oil from oil tankers and offshore drilling rigs, accidentally or intentionally. An example of accidental oil discharge was the release of about 1 lakh metric tons of Kuwaiti oil on March 18, 1967. No, on March 18, 1967, when the ship ran aground off Cornwall near England and broke into three pieces. The Royal Air Force spent several days trying to set the oil a fire with high explosives. Even now, several large tanker accidents are occurring every year. The most serious environmental hazard in living history was caused by the spilling and burning of tremendous quantities of oil emanating from the Kuwaiti oil wells, which were blasted off in the Gulf War by the Iraqi troops when they were forced to retreat. The awfully hazardous pollution which was caused to the surrounding atmosphere and adjoining oceans was unprecedented. Enormous damage was done to aquatic life. Oil is also discharged from oil tankers intentionally. A tanker carrying a cargo of crude oil, after discharging the oil at the seaport, fills up its tank with seawater to act as a ballast on the return trip. Before the tanker docks, the seawater ballast contaminated with small residues of oil left in the tank is returned to the ocean. Some vessels which use oil fuels also tend to produce oil slicks when waste oil or seawater blast is dumped into ocean from their fuel tanks. The most adverse effect of oil pollution is on the sea parts. The oil penetrates their feathers, displacing the air which is normally trapped in feathers and provides buoyancy and insulation against cold. The elimination of entrapped air makes the bird colder and more susceptible to disease. In the absence of entrapped air, the bird experienced difficulty in flying. For instance, about one lakh birds lost their lives, and when the Kuwaiti oil tanker met with an accident on March 18, 1967, oil pollution adversely affected the other oceans life as well. Some of the constituents of oil, such as 3,4 benzpyrene, are carcinogenic. 10th, detergent. Detergents comprise of surfactants, that is surface active agents, which are organic compound having polar and hydrophilic groups such as COH, SO3H, NH4 positive or non-polar groups soluble in water. Some common detergents are given there like quaternary ammonium salt, alkyl benzene sulfate, where R1, R2, R3 are straight hydrocarbon chains, R4 is an aromatic chain, X is halogen acid group, M is cation such as Na positive. The surfactants in detergents cause a variety of pollution problems, some of which are as follows. The surfactants are highly resistant to the action of biological agents and thus do not undergo biodegradation. Since the surfactants tend to retain their identity, their elimination from municipal waste water by the usual treatment become problematic. Surfactants tends to inhibit oxidation of organic substance present in wastewater by forming a sort of envelope around them, with the result that these substances do not undergo oxidative degradation during the treatment of wastewater. These substances, generally being toxic, cause severe water pollution to which there is no remedy. Being surface active, the surfactants cover the surface of small particles in colloidal suspensions, thereby stabilizing them considerably. These colloidal particles does not aggregate and hence cannot be easily filtered off during subsequent treatment. The stabilized colloidal particle also reduce the activity of biological filter beds and activated sludge. The most undesirable effect of surfactants is their tendency to produce stable foam in rivers, sometimes several meters high, especially at lockets. These foam extend over several hundred meters of the river waters. The builders used in the preparation of detergent mostly consist of sodium phosphate, which forms stable soluble complexes with hardness liberating ions such as Ca2 positive and Mg2 positive. These complexes act as plant nutrition and support rich growth of aquatic plants, which deplete dissolved oxygen when alive and produce disagreeable smell on decay. In the view of above problems, research is now going on to discover surfactants which are biodegradable and builders which are non-phosphatic. Treatment of domestic wastewater.
The composition of municipal sewage depends largely on the wealth and habits of municipal population and the amount and the nature of industrial wastewater added to the domestic sewage. Sewage treatment processes are designed to remove oxygen-demanding organic wastes, suspended and dissolved solid, and bacteria. The treatment process are generally divided into three categories: first, primary treatment process; second, secondary treatment process; and the third one is tertiary treatment process, and these are discussed here. First, primary treatment process involved removal of grade, screening, grinding, flocculation, sedimentation, skimming. System of grade removal and screening are designed to remove large suspended or floating materials such as rags, paper, twigs, wires, root, glass, and other metals. The material removed by screening are incinerated or buried. Flocculation is carried out by agitating wastewater by mechanical stirrers or air injections. This causes small suspended solids to collide and form bigger aggregates which settle down more rapidly. Sedimentation, that is removal of suspended solids by gravitational setting, which is carried out in large basins having a continuous flow and detention time of 4 to 6 hours. Specific wastes from industrial sources are subjected to removal of oil or grease in a skimming tank, neutralization of excessive alkalinity or acidity, and precipitation or ion exchange treatment for heavy metals. Secondary treatment process include the use of biological method employing trickling filters and activated sludge plants. The use for both the technique is described below. Use of trickling filters comprising of pads of crushed stone embedded with biological streamers. Wastewater is allowed to percolate through these beds. When the organic matter present in wastewater get absorbed on slimes and undergo decomposition by bacteria and fungi present in slimes, when the slime layers become very thick, this law of and can be easily removed. Activated sludge process. This process involves continuous circulation of biologically active growths through wastewater in the presence of oxygen splites as fine bubbles of compressed air. The suspended and dissolved organic waste is well aerated and mixed undergo adsorption, flocculation, oxidation, and biological degradation. After a few hours, the sludge is transferred to sedimentation tanks and allowed to settle out. A part of sludge which is not rich in organisms is used to seed the next branch of wastes from the primary settling tanks. The activated sludge performs two functions. First, it clarifies the water by absorbing most of colloidal and suspended solid on the surface of sludge particles. It causes oxidative degradation of the organic matter present in wastewater. The sludge from secondary treatment plant is disposed of in several ways. A common method consists in digesting the sludge in circular digester 6 to 10 meter deep, which are maintained at a temperature of about 35 degrees Celsius. During digestion, the amount of the organic matter is eventually reduced to gases consisting of about 70% methane, 30% CO2 with smaller amount of NH3H2S, H2N2. Methane is recovered and used as a fuel for heating the digester. After digestion, for a few weeks, the sludge get converted into stable humus material, which is used as a soil conditioner. Third one is the tertiary treatment process, advanced wastewater treatment process, also called it. These processes aim at improving the wastewater quality to the point at which it can be reused. The increasing cost of water supplies and the increasing emphasis on wastewater quality are leading engineers to devise methods for total recycling of decontaminated water. Some common advanced wastewater treatment processes are discussed here. Chemical coagulation and filtration. In this process, the wastewater treated with chemical coagulants such as alum, ferric sulfate, ferric chloride, etc., as a result of which the suspended matter get coagulated to form flocks. In recent years, a number of synthetic high molar mass water-soluble polymers have been developed as highly effective coagulants. On one such coagulant is Calgon. One such coagulant is Calgon with polydiallyl dimethyl ammonium chloride. The flocks are filtered with the help of sand, diatomaceous earth, or several other Multimedia filters, micro screens can also be used for this purpose. Carbon adsorption. The wastewater is treated with activated carbon, which is porous and highly adsorbent form of carbon with a large surface area. This treatment, because of adsorption, eliminates material responsible for undesirable tastes and odors. Chemical oxidation. Wastewater treatment can also be carried out by the strong oxidants such as ozone, hydrogen peroxide, chlorine, and chlorine dioxide. However, oxidants do not eliminate the dissolved inorganic compounds which are present in wastewater. Even after secondary treatment, these compounds are removed by ion exchange, electrodialysis, and reverse osmosis. The techniques are discussed here also. Ion exchange. Ion exchange can be carried out by using ion exchange resin, cation exchange resin. Exchange their H positive ions for metallic cations present in wastewater, whereas anion exchange resin exchange their OH negative ions for chloride and other anions present in water. The resin are conventionally regenerated by treatment with sulfuric acid for cationic resins and sodium hydroxide for anionic resins. Ion exchange process is highly effective and produces high quality water. Electrodialysis. In this process, the wastewater is exposed to an electrical potential difference in big tanks which are fitted with membranes consisting of sheet of ion exchange resins. These sheets are permeable to only cations or only anions. The anions and cations present in wastewater thus migrate through the membrane towards the anode and cathode. Electrodialysis do not eliminate the organic matter from the wastewater. Reverse osmosis. In this process, wastewater is separated from fresh water by a semi-permeable membrane, which is permeable to water but not to the dissolved material. Pressure considerably higher than the osmotic pressure of wastewater is applied on the wastewater. As a result, which pure water is forced to the other side of the membrane. This process is known as reverse osmosis. It eliminates organic as well as inorganic matter from wastewater. The rate of flow of water through semi-permeable membrane is given by QW is equal to del P minus del pi gamma W A upon rho. Depending upon the salt concentration, the osmotic pressure of domestic waste water are considerably high. This implies that for effective treatment of waste waters, the pressures to be applied for reverse osmosis and considerably high. For quite some time, it was a problem to have commercial semi-permeable membrane which could withstand with high pressures. These days, however, the problem of the availability of such SPM has been completely solved. SPM semi-permeable membrane for reverse osmosis were first obtained in late 1950s from cellulose acetate, but their use in reverse osmosis was impractical since being dense. They permitted very low flow rates. A few years later, techniques were developed for the fabrication of cellulose acetate membrane with asymmetric density by using proper casting solution composition and proper casting membrane and quenching condition. It has been now possible to prepare cellulose membranes within 0.1 to 1.0 dense surface termed as skin of the membrane supported by porous cellulose. These membranes permit high water flow rates since the rate determining factor for water transport is only the thickness of skin of the membrane, which is now evidently very small. Still, better semi-permeable membranes have recently been obtained from aromatic polyamides. It is to be clearly understood, however, that none of membrane prepared so far is perfectly semi-permeable. Some quantities of salt almost invariably pass through the membrane. Since, however, this quantity are very small, their presence does not pose any pollution problem. Industrial wastewater, its contamination and treatment. Industrial wastewater is invariably contaminated. The nature of the contaminants depending upon the industries from which the wastewater is obtained. These aspects are discussed here. Wastewater from food processing industry. Food processing units such as beet, sugar refining, brewing, distilling, and canning, etc., dealing with meat and dairy products yield wastewater which contain high content of decomposable organic matter, which leads to heavy oxygen depletion. The dairy industry produce organic wastes high in protein, fats, lactose. The beet, sugar refining industry products wastes which have a high biochemical oxygen demand, that is BOD. Breweries and distilleries produce organic solid and included fermented starches. The processing of food to produce canned and or frozen products leads to large amount of wet solids. The wastes from meat processing industries are associated with blood, fats, proteins, feathers, and other organic wastes, and so on. Wastewater from textile industry. The wastewater from textile mills is generally alkaline and has a high biochemical oxygen demand. The textile waters arise from impurities in the fibers and from chemicals used in processing, with cooking the fibers, dazzling the fabrics, etc. Wastewater from paper and pulp industries. The effluents from paper and pulp industry contain chemicals used in the craft process. Bits of barks, wood chips, cellulose fibers, and dissolved lignin. About 50% of the wood used as input in is eventually discharged as wastewater. The effluents contain compounds which are toxic to fish and shellfish. Wastewater from chemical industry. The wastewater from chemical industry is very highly contaminated. Chemical plants manufacturing acid-based pesticides, synthetic fibers, detergent, and many other organic and inorganic compound produces wastes which are associated with a wide variety of contaminants numbering into thousands, and many of which are highly toxic. Wastewater from petroleum industry. Wastewater from oil drilling includes drilling muds, brine pumped out of well along with crude oil and some oil as well. Oil refineries and petrochemical plants yield a large number of contaminants such as hydrocarbons, acids, alkalis, cyanides, numerous sodium, salt, phenolic compounds, inorganic and organic sulfur compounds, and halogenated hydrocarbon. Many of these compounds generate undesirable odor and the taste is, and many of them cause fish flesh to acquire adverse taste. Wastewater from metal industries. Steel mills produce wastewater from cooking of coal, washing of blast furnace, flue gases, and pickling of the stick. These wastes contain phenol, cyanogen, cork, limestone, meal, scale, and fine suspended solids. The wastewater may also contain metals such as chromium, lead, nickel, cadmium, zinc, copper, silver, as well as acid alkaline cleaners, grease, and oil. Wastewater from metal plant plating industry is highly toxic on account of the presence of metal cyanides. Wastewater from other industries. Wastewater from other industries are associated with a wide variety of contaminants. For instance, leather tannery wastes contain high content of solid salt causing hardness, sulfides, chromium salt, and lime. These wastes have high biochemical oxygen demand, that is BOD. Radioactive wastes originate from nuclear power plants and research laboratories using radioisotopes. Soft drinking bottling plants produce highly alkaline wastes with high BOD from the washing of bottle, which involve removal of cigarette butts, paper, and other debris left in the bottle by previous users. Laundries have turbid wastes that are alkaline and contain organic solid, and so on. Treatment of industrial waste. It is evident from the above discussion that if industrial waste is discharged into lakes, rivers, or oceans, as such, it would cause severe pollution. The wastewater thus has to be treated properly before it can be disposed of. Most of the water treatment methods used by industries are in general the same as used by the treatment of municipal wastewater. However, some specific treatments have been used with the advantage in specific cases. For example, while biological treatments are more suited for wastes from dairy and food industries, chemical treatments have worked well for wastes from metal plating industries. Since large amount of water are required by many large industry, there is great emphasis on subject industrial wastewater to advanced treatment, with treatment tertiary treatments to render the water suitable for use. These treatments are essentially the same as carried out in case of municipal wastewater. Thank you.